5G doesn't just use one channel, it can combine several at once to multiply data rates. In this episode of 5G RF Features Explained, you will see how carrier aggregation and dual connectivity actually do that, turning the same spectrum into more capacity. Let's find out more how 3GPP made it possible. Let's start with carrier aggregation. First introduced in LTE Advanced and enhanced in 5G New Radio. It allows the network to combine multiple component carriers to form a wider effective bandwidth, boosting user data rates. Each component carrier can belong to the same or different bands, known as intra-band and inter-band CA. In 5G, New Radio supports up to 16 downlink component carriers and 8 uplink component carriers, enabling gigabit-class speeds and efficient use of fragmented spectrum. Here is a comparison table of carrier aggregation between LTE and 5G New Radio. Feel free to pause the video and explore the details. Carrier aggregation can be configured in several ways: intra-band contiguous, intra-band non-contiguous, and inter-band. These configurations help operators combine spectrum fragments they already own. In FR1, carrier aggregation enhances capacity. In FR2, it extends coverage by combining millimeter wave and sub-6 GHz carriers. For example, aggregating two 20 MHz carriers in band N78 and one 10 MHz carrier in band N1 gives a total of 50 MHz bandwidth. This setup improves throughput significantly and is a common configuration in middle-band deployments. Now, let's look at dual connectivity. Unlike carrier aggregation, dual connectivity allows the device to connect to two different nodes simultaneously. In EN dual connectivity, LTE serves as the master node and the New Radio as the secondary node. In New Radio DC, both nodes are New Radio based, providing even greater flexibility in standalone 5G networks. In ENDC, the control plane runs over LTE, while user data is split between LTE and the New Radio. This approach enabled early 5G deployments to use existing LTE coverage as an anchor, while New Radio handled high-speed data. It's the backbone of non-standalone 5G systems. Although both carrier aggregation and dual connectivity combine resources, their mechanisms differ. CA aggregates multiple carriers managed by one node, tight physical and MAC layer coordination. DC connects to separate nodes coordinated at the PDCP layer. Think of CA as multiple lanes from one tower, and then DC as two roads from two towers converging at your phone. Operators often combine middle-band and low-band carriers such as N78 and N28 to balance capacity and coverage. ENDC is widely used in non-standalone deployments, leveraging LTE as an anchor. New Radio DC, meanwhile, supports dual New Radio nodes further enhance standalone 5G performance. Carrier aggregation and dual connectivity together forms the foundation of multi-carrier 5G performance. They increase throughput, enhance reliability, and enable flexible deployment. In our next episode, we'll explore massive MIMO and beamforming, the spatial dimension of 5G RF magic. That's all for today. If you like this video, please subscribe, like, and share. Thank you.